Welcome back. Now that we know how to calculate the components of a TPN order, we need to make sure the order is safe and appropriate for the patient. Because in parenteral nutrition, we are delivering the nutrition directly into the patient's vein, there are 3 really important safety checks that we have to evaluate when writing a TPN order. And those are dextrose, as measured through the GIR or the glucose infusion rate, the amount of fats, making sure that it's less than 2.5 grams of fat per kilogram per day. Finally, for peripheral parenteral nutrition only, we have to check the osmolarity. That's the concentration of solutes in the solution. Your peripheral veins can't tolerate very concentrated solutions, so the total osmolarity needs to stay under 800 to 900 milliosmoles per liter. GIR tells us how fast the dextrose is being infused into the bloodstream. If the rate is too high, the patient can become hyperglycemic or develop hepatic steatosis. We calculate the glucose infusion rate by looking at the amount of dextrose per kilogram of body weight per minute. Infants can have the most dextrose administered per minute. Approximately 10 to 14 milligrams of dextrose can be administered per kilogram of body weight each minute. For children, that goes down a little bit, and adolescents, it goes down even more. When we're talking about adults, we generally want to stay under 5 milligrams per kilogram per minute. Calculating GIR depends on the units. Milligrams of dextrose provided per kilogram of body weight per minute. So grams of carbohydrates in milligrams, this is dimensional analysis. There are 1,000 milligrams in a gram, so multiply grams of carbohydrates by 1,000 milligrams. Weight needs to be in kilograms, so if weight is given in pounds, you'd use the equivalent statement of 2.2 pounds in a kilogram. And then instead of thinking of glucose infused per day, the more appropriate time interval is in the short term, so we use minutes. In one day, there are 24 hours, and there's 60 minutes in an hour, meaning there's 1,440 minutes in a day. So to find the GIR, the milligrams of glucose provided per kilogram of body weight per minute, you just divide all 3. In your calculator, take milligrams of carbohydrate, divide key, kilogram of body weight, divide key 1440. And you'll most likely be asked about adults. For adults, the GIR is 5 milligrams per kilogram per minute or less. For adolescents, it's a little bit more, and for children, it's even more. And for infants, it's the most, 10 to 14 milligrams per kilogram per minute. Next, we also need to check the fat load. For adults, the safe upper limit is less than 2.5 grams of lipid per kilogram of body weight per day. If we exceed that, we risk overloading the liver or suppressing the immune system. And so the way you figure this out is you take the grams of fat that you're administering and just divide it by the kilograms of body weight. It's way easier than GIR because you can keep your fat in grams, exactly what you get in your calculation, and then just divide it by kilograms of body weight. Finally, the last check to remember is in peripheral parenteral nutrition, PPN. We have to check the osmolarity, which again is the concentration of the solutes that are in the solution. So the way we do this is by using the approximate osmolarity contributions from each component. Dextrose has 5 milliosmoles per gram, and that's an equivalent statement. So if you know the amount of dextrose that's being provided either per liter or per day, we can use the equivalent statement to figure out the osmolarity component of the dextrose. And when it comes to amino acids, it's twice as much. There's 10 milliosmoles per gram of amino acids. Lipids have essentially no milliosmoles per gram. So to find the osmolarity, you'll take the grams of dextrose and amino acid and then use the equivalent statements to determine the total osmolarity. If the osmolarity is too high, we risk vein damage, which would mean we can't use peripheral parenteral nutrition anymore, and we would have to change it to central access. And some folks do not have central access. So keeping osmolarity in mind when we're doing PPN is really important. So let's talk again about the calculations that we need to do in these parenteral nutrition problems. We have the same 3 steps that we had before. To determine the goal volume, to determine the total nutrition provided by that volume. If we're giving a recommendation, then our 3rd step is to check and state that recommendation. But these steps are basically what we lined out in the first part of this lesson. So to determine the goal rate, we need to look at the estimated needs. We'll calculate the infusion rate and we'll determine the total daily volume. To figure out the total nutrition provided, we want to look at the estimated needs to first come up with our amino acid concentration. From the AMDR, we'll calculate our fat calories. And if you are a little weak on AMDR still, it's a recommendation of about 30% fat of total calories. And then from the remainder, so we'll figure out how much is being provided from amino acids. We'll figure out how much is being provided by fat. From the remainder, we'll determine the percent dextrose that we are administering, keeping in mind GIR, the fat load, and if it is a peripheral problem, the milliosmolarity of the solution. And then when we state our parenteral nutrition recommendation, we do dextrose as a percent, amino acid as a percent. If it is a 3-in-1, we would put our lipid as a percent. If it's a piggyback, we would say just what the rate is, and then the fat volume, the fat percent, and how many days we administer the fat separately. And again, this is what you would document or communicate to the team. Stating the recommendation is more a clinical focus. It is less likely to be something that they ask you on the exam, but the calculations and the logic are exactly the same. So let's work through some TPN order problems so we can practice with these calculations. In this first one, we have a 90 kilogram patient who has estimated needs of 2,000 calories, 85 grams of protein, 2,000 milliliters of fluid, and we are trying to write a TPN order here. This is not a question I would expect you to get on the RD exam because there's quite a few different TPN orders that you could write that would be valid and would meet these patients' needs. But I just want to walk through these steps. So let's do this one together. To write an order, we start with the patient's volume needs. If this patient was being fed continuously, because it doesn't say to just feed them for a few hours, what is the hourly infusion rate? And so what is our daily volume of TPN that we're providing? So since this patient needs 2,000 fluid milliliters every single day, and every day has 24 hours, then we're talking about 83.3 milliliters needing to be provided every single hour, which I'm going to round to 85. So my daily volume, I can convert from hours to days because there's 24 hours in one day. Hours cancels out. And I find out that if I'm feeding my patient 85 milliliters an hour, then they're getting 2,040 milliliters every single day. That's my hourly infusion rate, 85 milliliters per hour. And my daily volume is 2,040 milliliters every day. Next, using the estimated needs, we'll determine the amino acid concentration. This patient needs 85 grams of protein. So we're trying to figure out the percent amino acid here. We are feeding them 2,040 milliliters of our solution, which comes out to be 4.16%. I was taught to round to the nearest quarter percent. So I would call this 4.25%. And since I'm changing it now, I need to figure out how many grams of protein this is. If it's 4.25% amino acid, and we're feeding them 2,040 milliliters of solution, I can do a little bit of algebra here to figure out a 4.25% amino acid solution is 87 grams of protein. 85 grams of protein, 87 grams of protein. Regardless, we can determine how many calories that is because there's 4 calories in every gram of protein. So if we're using 87 grams of protein, because we're rounding 4.16 to 4.25, then we come out to 348 calories from protein. To find the amount of fat calories, we're going to use the AMDR, the acceptable macronutrient distribution ranges. And for fat, that's about 30%. 30% of total calorie needs, and this patient is taking in 2,000 calories every single day. So 30% of 2,000 calories is 600 calories from fat. If we were doing a 3-in-1, we're done. But just to review these piggybacks, we can look at a 20% lipid emulsion. We can look at a 10%. We could even look at a 30%. But the way we'll determine how much of this lipid piggyback we would need is to take the amount of calories from fat and remember the equivalent statements for each of these. So depending on which of these piggybacks you use, you would not use both. You would pick one. You would need 300 milliliters of the 20% fat emulsion, or you would need 545 milliliters of the 10%. Now, to figure out the amount of dextrose, we subtract it. This patient needs 2,000 calories a day, and we already found out that we're going to give them 348 calories from amino acids and 600 calories from fats. Because we're feeding patients directly into their bloodstream, we really need to be conscious with the amount of sugar that we are pumping right into their veins. So to find the calories from carbohydrate, it's the remaining calories left in the day. This patient, again, needs 2,000 calories every day. We subtract the calories from amino acids. We subtract the calories from fat. This patient still needs 1,000 calories to get their needs met. And we can figure out how many grams of dextrose that is because 1 gram of dextrose is 3.4 calories. If we need 1,052 calories from dextrose, then we need 309 grams of dextrose to be provided in order for that patient to have the 1,052 calories from dextrose so that the total calories from the TPN come out to be 2,000 calories per day. But hopefully you'll remember when it comes to amino acids and dextrose, we give the amounts as a percent. So as a percent, we're giving 309 grams of dextrose in the 2,040 milliliters of solution, which is 15%. So that's how we figure out the specific nutrients that are provided in a TPN solution in order to meet the patient's needs. But also remember that when we're doing TPN, there are a few important things that we have to check. Firstly, we need to check the GIR. GIR is milligrams of dextrose per kilogram per minute. So we'll take our grams of carbohydrate that is being provided, 309 grams. We need to convert that to milligrams, so we'll multiply it by 1,000. Then we'll divide by the kilogram of the patient's weight, 90 kilograms. And then to get it into minutes, we divide by 1,440. So when we plug all of that in, we come out to be 2.38 milligrams per kilogram per day, which is below 5. 5 is the maximum for adults, so it checks out. But in parenteral nutrition, we also need to check the fat. So we are providing 600 calories from fat. And the general guidelines are to keep total fat provided less than 2.5 grams of fat per kilogram of body weight. Since TPN fat solutions provide about 10 calories per gram of fat, 600 calories from fat is equal to 60 grams of fat. Dividing the grams of fat given by the patient's body weight in kilograms will allow us to complete our second check. 60 grams of fat administered to a 90 kilogram person is less than 2.5. So that also checks out. Now, this is a TPN problem, and the central vein can handle higher osmolarities, so we don't need to meet that 800 to 900 milliosmol threshold of ppn, which means we can just state our recommendation, which is the percent of dextrose plus the percent of amino acid. For dextrose, we have 15% dextrose. We have 4.25% amino acids. We are administering this at 85 milliliters per hour. For our 20% fat lipid emulsion, we need 300 milliliters of it. And for our 10% fat emulsion, we need about 550 milliliters of it. We also don't need to administer this fat every single day. We could have broken it down so that we give it 2 times a week or 3 times a week or 4 times. And that's why a problem this involved won't show up on your exam. But you should expect any and all of these calculations in more targeted problems. If you're feeling overwhelmed in nutrition support calculations, try to take a breath. Nutrition support is one of the most challenging but important sections of the Math Essentials unit, and applications of it are guaranteed content areas for your RD exam. But you can do it, and even the most nuanced problems will rely on your skills with dimensional analysis and percent conversions. These nutrition support videos will come up again in Module 4, so you'll have plenty of time to reinforce it. But it's important to not let it fall off your radar. In the Bridge app or website, you can bookmark lessons, and on YouTube, you can save. As we go through the rest of the course, bookmark the videos of topics that you feel weak on, and watch those videos again and again. Bridge is intentionally broken up to give you an opportunity between topics to identify your weak areas, to review them, to progress on, and eventually succeed. At least that's the goal. And right now, you are exactly on track. So keep going. I'm proud of you, and I will see you in the next module on nutrition physiology.